This lecture is on finding the domain of a rational function, and so there are a couple of things that I want to talk about before we get into talking about the domain for a rational function. First, what a rational expression is. So a rational expression is an expression that can be written as the quotient of two polynomials. So p of x divided by q of x, where p of x is a polynomial and q of x is also another polynomial. And we need to make sure that this q of x polynomial that's in our denominator is not equal to 0 because dividing by 0 is undefined. So again, a rational expression is some polynomial divided by another polynomial as long as the polynomial in the denominator on the bottom is not equal to 0. So that's the definition of a rational expression. A rational function is just a function that's equal to a rational expression. So our examples here are all rational functions. So we have f of x equals 2x plus 3 over 4 is an example of a rational function. The domain of any function is the set of all real numbers, okay, let's do that over again. The domain of a function is the set of values for x, and so all real numbers except for the values that make the denominator equal to 0 when we're talking about a rational function, because again, dividing by 0 is undefined, and so we can't do that. And so any values that will cause you to divide by 0 are not part of our domain, so we're going to take those out of our domain. Another thing I want to talk a little bit about is that when we write the set of values that are in our domain, we're going to use interval notation. And when we're writing out interval notation, the round bracket will mean not included. And if we write a square bracket, then it means that that value is included in the set or in the interval. So round bracket means that that value is not included. A square bracket means that it is included. So our first example here, f of x equals 2x plus 3 divided by 4. So the denominator for this one is 4. And no matter what x is, this denominator is always just going to be 4. And so the domain for this one is the set of all real numbers. Because there aren't any real numbers that will cause us to divide by 0 in this one. So we're always going to start off assuming that the domain is a set of all real numbers, and then we'll remove anything that causes us a problem. So there are a couple ways that you can write that. One way is to just write it out like this, set of all real numbers. Or you could use the symbol for the set of all real numbers, which is this capital R, but it has the 2 lines in the back. Or the interval notation. And this is really what I prefer that you write. And so negative infinity up to infinity is this how we would write the set of all real numbers as an interval. Our next example, f of x equals, and there's a negative sign out in front of this fraction, and then it's positive 6x plus x squared over 5x. So we start off assuming that it's all real numbers, and then we look for problems. So I have a 5x in my denominator. So whatever value of x will cause this to be 0 is the value that we need to take out. So you set your denominator equal to 0 and solve, and this will give you the values that we need to remove from our domain. So we're going to divide both sides by 5, and that will give us x, and then 0 divided by anything is 0, so this gives us x equals 0. So this is the value that I need to remove. And so we start off at negative infinity, and then you go up to your problem. The problem occurred at 0, and now if I put a round bracket here, it's anything that's smaller than 0, so negative infinity, up to 0, but not including 0. That's what this round bracket does. It takes this particular value out of our interval. We use a big capital U, it's called a union symbol, and it joins two sets together. And we start up right where we left off using a round bracket. This round bracket takes the 0 out of our domain, and we go up to positive infinity. So negative infinity to 0 with a round bracket, and then union 0 up to positive infinity. So this is all real numbers, except for this one value, 0, that we're removing using these round brackets. Example C, f of x equals 2 minus 5x over negative 7 plus x. So again, you take your denominator, negative 7 plus x, set it equal to 0, and solve for x, and that will give you the values that we need to remove from our domain. So we're going to add 7 to both sides of this, and that will give me x is equal to 7. And so this is the value I need to remove. And we start at negative infinity. And we always use a round bracket at any infinity because we can't include infinity in an interval, because if I try to say what infinity is, you'll give me one bigger, and then I can give you one bigger, and we could keep on going back and forth like that all day. And so there's no way for us to include infinity in an interval. So we always use a round bracket at infinity. We go up to the value that we need to remove, which is 7. Use a round bracket that takes 7 out of our domain. And then the big capital U, we pick up right where we left off at 7, and then we go up to positive infinity. So this is all real numbers except for this one value 7 that we've removed using those round brackets. In our next example here, f of x is equal to x over 2x squared plus x minus 3. So we need to factor the denominator so we can solve it. We have 2x squared plus x minus 3. We're going to set that equal to 0. That will give us the values that we need to remove from our domain. And so this would be a good problem to do the guess and check method on for factoring. The only way for us to factor this 2x squared is to factor it as 2x times x. And then the only way for us to factor the 3 is 1 times 3. So we'll try a 1 in the first set and a 3 in the second set to see if that's the right way. So when we multiply our inners, we would get 1x, and when we multiply our outers, we would get 6x. And there's no way for us to create this positive x that's in the middle with a 1x and a 6x. So I've done this the wrong way. We need to change the 1 and the 3. I should have done a 3 here and a 1 here. And when I change that, then when I multiply my inners, I get 3x. And when I multiply the outers, I get 2x. I need to end up with a positive x as my middle term, so I need this 3x to be positive. And this is the multiplication we do to get that 3x, so this needs to be plus. And then to get positive x from adding these two together, this will need to be a negative 2x. And so we need to get negative 2x when we do this multiplication, so that needs to be minus. So that's how it factors. When you have two things that are multiplied together that give you 0, it means that one of the two things has to be 0. So either 2x plus 3 equals 0, or x minus 1 equals 0. So subtract 3 from both sides, and we get 2x equals negative 3, and then divide by 2. And so we get x is equal to negative 3/2. Here we would add 1 to both sides, and we get x is equal to 1. So I have two values that I need to remove from my domain this time. So we always start off at negative infinity. And then you're going to go to the smallest problem, and our smallest problem is this negative 3/2. Negative 3/2 is smaller than positive 1, so we're going to go up to that, negative 3/2. Use a round bracket, it removes the negative 3/2 from our domain, and then we use a big capital U to join on a new set. And then we're going to start right where we left off, so start right at negative 3/2. Then you go up to the next problem, and our next problem was 1. The round bracket takes that 1 out of our domain. The union symbol to join the two sets together. Pick up right where you left off at 1, and then 1 was our last problem, so we go up to positive infinity. And so there is how we would write out our domain if we have 2 values that we need to remove. In our last example here, f of x is equal to x squared plus 3x minus 5 over x times x plus 2 times x minus 5. So this time they have the denominator factored for us already, so that's nice. So we know that either x has to be equal to 0, or x plus 2 is equal to 0, or x minus 5 equals 0. Make sure you can see that. So we have one value right away. To get the second value, we would subtract 2 from both sides, and so that gives me x equals negative 2. And then for the third one, we would add 5 to both sides, and that gives us x equals 5. So this time we have 3 values that we need to remove, 0, negative 2, and 5. So we're going to start at negative infinity, and then we go up to our smallest problem, and the smallest number between the 0, negative 2, and 5 is this negative 2. So we're going to go up to negative 2. We use a round bracket. That removes the negative 2 from our domain. Join the 2 sets together with the union symbol, and then pick up right where we left off. So that's at negative 2. Let me move that a little bit. And then we go to the next number, and so the next number would be 0, because we want the smallest one next, and the smallest one left would be the 0. Using the round bracket removes the 0 from our domain. Use the union symbol to join the sets together, and then we pick up right where we left off at 0, and we go up to the final problem, which is 5. Using round brackets to take those values out of our domain, and then the union symbol to join our sets together, and then from 5 to infinity. So again, we've got the negative 2 removed right here, we've got the 0 removed right here, and this takes out the 5. And so that is how we would write the domain if we're removing 3 values. And that finishes off our lecture on the domain of a rational function. Let me know if you have any questions.